In this video, we're going to talk about how to graph the sine and cosine wave. Sine and cosine are periodic functions, meaning that they repeat, and we learned that in Chapter 2. If you can remember in Chapter 2, we said any angle that is coterminal with an angle, and let's just say this is pi over 4. Any angle that's coterminal with this angle, okay, so we can make complete revolutions and get more than one angle that's coterminal. We can do complete revolutions both forwards and backwards to get coterminal angles. So we could say negative 7 pi over 4 is coterminal. We can say 9 pi over 4 is coterminal. Coterminal angles have the same sine and cosine values. So that means every time you go around your unit circle, say you go around your unit circle once, you will get one graph or one complete period for sine. If you go around it again, you will get a second complete period for sine or cosine. So we call those periodic functions because their graphs and their values repeat. And you'll see that when we start graphing our sine and cosine function. So the way that we say this algebraically is that we say the sine and cosine repeat every 2 pi, which can be represented as, I want my red pen back, as this expression, where we can plug in any integer value for n. So if we have an angle, say x, if x equals pi over 4, we can add or subtract, depending on what n is. If n is positive or n is negative, we could add or subtract multiples of 2 pi. So we could get, I know 2 pi as a fraction over 4 is 8 pi over 4. If we multiply that by a negative 1, we get our negative 7 pi over 4. If we multiply it by a 1, we get our 9 pi over 4. If we multiply by 0, if n is 0, we just get pi over 4. So that calculates all of the coterminal angles. So all that statement is saying is that the sine of x equals the sine of any of its coterminal angles. So let's go ahead and graph the sine of x. On the right-hand side, I used my unit circle to come up with these values right here. Okay, I took a look at the radian measures of 0, pi over 2, pi, 3 pi over 2, and 2 pi, both in a forwards direction and in a reverse clockwise direction, and I found the sine value. And when we plot sine and cosine, we're only going to be looking at quadrantal angles. So this chart is really, really handy. If you have this available to you, it'll make your graphing a whole bunch easier. So these represent our ordered pairs. So I'm going to plot my ordered pairs. I have a 0, 0. At pi over 2, sine is 1. At pi, sine is 0. At 3 pi over 2, sine is negative 1. And at 2 pi, which is back again, it's coterminal with 0, sine is 0. So I'm going to go ahead and plot that. And then I'm also going to plot, this is called one period, by the way. This is one period. When I go ahead and graph another period, my graph will look exactly the same. So this graph does not repeat, and it includes the entire picture of one sine wave. And since it includes the entire picture, it is called one period of the sine wave, and it has a distance of 2 pi since it goes from 0 to 2 pi. If I plot backwards along my unit circle, at negative pi over 2, I'm at negative 1. At negative pi, I'm at 0. At negative 3 pi over 2, I'm at 1. And at negative 2 pi, I'm at 0. So when I look at this graph, you can see it looks exactly the same as the other period of sine. Here's one more period of sine, and it also has a distance from negative 2 pi to 0 is a distance of 2 pi. So what is the domain of my sine function? What are the kind of numbers that I can plug in for x? Well, the domain, I can plug in any real number. Okay, if you calculate on the calculator these x values, they come out to be decimal values, and you can plug in any number that you want into the sine function, and it will end up somewhere along your unit circle. The range, though, does go, and we talked about the range of sine and cosine. It goes from negative 1 to 1. That is the maximum and minimum y value you will ever calculate out of sine. And we showed that the period of this function is 2 pi. So now let's go ahead and graph our cosine function. So again, I took the liberty of creating a table of all of my cosine function values at our quadrantal angles. So I'm going to go ahead and graph them on my axes. At 0 radians, cosine has a value of 1. At pi over 2 radians, it has a value of 0. At pi radians, it has a value of negative 1. At 3 pi over 2, it has a value of 0. And at 2 pi, it has a value of 1. So now I'm going to draw in my curve, and my cosine function looks like this. So now if I go backwards around my unit circle, if I do negative pi over 2, it has a value of 0. Cosine of negative pi has a value of negative 1. Cosine of negative 3 pi over 2 has a value of 0. And the cosine of negative 2 pi has a value of 1. So when I draw this graph in, it looks exactly like my first period did. Okay, you can clearly see that this graph, I get a complete snapshot of this graph from 0 to 2 pi. If I include any more, I'm going to get pieces of repeating parts. So I say the period here is 2 pi because it is a complete snapshot of my cosine function without any of the repeating parts. So again, the domain is negative infinity to infinity because I can go around my unit circle as many times as I want to find an angle, or backwards as many times as I want. The range, again, the highest and lowest y values, negative 1 to 1, and they're inclusive of all the y values in between. And because a complete snapshot of my cosine wave happens from 0 to 2 pi, my period is 2 pi. So now let's talk about the amplitude of these graphs. The amplitude is half the distance between the max and min values of your sine and cosine wave. So let's go back to our sine and cosine wave. Its max value is at 1, and its minimum value is at negative 1. The distance between these two numbers is 2. So the amplitude of this is half of 2, which is 1. A cosine function has an amplitude of 1 because from its resting position at y equals 0, it goes up 1 unit and it goes down 1 unit. Okay, 1 unit up, 1 unit down, and that is the same on my sine wave. It goes up from the resting position of y equals 0, it goes up 1 unit, and it goes down 1 unit. Okay, so its amplitude is 1. Well, we can change that amplitude if we feel like it. Okay, just like we did in some of our other functions that we graphed, we don't have to have just like a normal quadratic graph. We were allowed to stretch and compress that graph. Well, we can do the same thing here. We can stretch and compress our sine graphs, and that's called changing the amplitude. So if I have a value in front of my sine or my cosine function, I am either stretching that function or compressing it. If that value, if the absolute value of a is greater than 1, that's called a stretch, and we are multiplying our y values. So we're multiplying our y values by a. If our a value, the absolute value of our a value is, let's see, this is going to be a times our y value. If our absolute value of a is between 0 and 1, that's called a compress. And again, we're still multiplying our y values because we're taking those y values and we're either multiplying them by a factor bigger than 1 or by a factor smaller than 1. So the graph of y equals a times sine, or y equals a times cosine of x, where a doesn't equal 0, will have the same shape as y equals sine of x or y equals cosine of x, except that all the y values will be multiplied by a. Very similar to our quadratic functions and our other functions, where if we sketch the graph of just the regular x squared function, it looks the same as if, like, it has the same shape as if we said 2x squared. All right, so let's go ahead and do 2 examples of graphing sine and cosine, and we're going to change the amplitude. So here we're going to take all of our sine values, right? And I have my sine values right here in my graph, and I'm going to multiply those by 2, and I'm going to plot them. So sine of 0 radians is 0, so I multiply that by 2 and I get 0. Sine of pi over 2 radians is 1, so when I multiply that by 2 I get 2. Sine of pi is 0, when I multiply that by 2 I get 0. Sine of 3 pi over 2 is negative 1, so when I multiply that by 2 I get negative 2. Sine of 2 pi is 0, so I get 0 when I multiply by 2. So now let's go ahead and do that backwards. Sine of negative 2 pi is negative 1, so I get negative 2. Sine of negative pi is 0, so when I multiply by 2, I get 0. Sine of negative 3 pi over 2 is 1, so when I multiply by 2, I get 2. And sine of negative 2 pi is 0, so when I multiply by 2, I get 0. And you can see when I draw this graph in that it looks very similar to my original sine wave. It has the same x-intercepts, and the max values and the min values happen at the same angles. All right, just their maximum and minimum values have been stretched. So this has an amplitude of the absolute value of 2, which is 2. All right, so in this example, let's calculate our amplitude first. So our amplitude is always going to be the absolute value of a. So the absolute value of negative 3 is 3, and this tells me I'm going to be multiplying all of my cosine values by 3. So I'm going to mark this 3 over here so that you can see I'm multiplying these y values by 3, and I'm going to go ahead and graph that to see what my, I'm multiplying by negative 3, I'm sorry. My amplitude is always positive, but I'm going to be multiplying by a negative 3. Okay, what will that do to my graph? Well, I don't know. So 1 times negative 3 is negative 3. 0 times negative 3 is 0. Negative 1 times negative 3 is 3. 0, I will get a negative 3 here. When I multiply by 0, I get a 0. When I multiply by a negative 1, I get a positive 3. And those I'll get a 0 and a negative 3. So when I draw it in, you can clearly see that the amplitude, the distance from the x-axis to the max and the min values, has a distance of 3. But that negative turned my graph upside down. So that is how I would like you to start your homework. Any of your graphs that have amplitudes, you can go ahead and graph tonight. If you would like to watch the next video, that'll be posted on tomorrow's assignment, and you can take a look at that.